Yeah, in this case, what is happening? Current lags the voltage by how much? 90 degrees. Okay. So this is the phasor diagram. This is the waveform. This is the phasor diagram. Keep that in the mind. Voltage will not change. Voltage will be as it is. In all the three circuits, voltage will be as it is. Now, I would like to little go ahead. What I want to go ahead, like I'll just tell you. See here, in this case, in this case, like suppose how what is happening in one cycle. Okay, suppose if it is like I'm just drawing a voltage signal and I'm explaining you what happens. Like suppose this is A, B, C, D, and E. Okay, this is quarter cycle. This is quarter cycle and this is quarter cycle. This is 1/4 first cycle, 1/4, 1/4, and 1/4. Okay, so this is a quarter cycle. Each one is quarter cycle. This is quarter cycle, then quarter cycle, then quarter cycle, then quarter cycle. Is that clear now? So I want to explain you what will happen.
Yes, sir.
So what is happening in the inductor? The voltage is physical explanation. Okay, that we have told like it is happening like that. But what exactly is happening inside the inductor, that I want to explain you now. Now A to B, when this pulse is increasing in the pulse is increasing in the inductor, what will happen? It becomes 0 to maximum. Okay, the current will become 0 to maximum. When the voltage is increasing, current is also in. But what will happen? The flux will set up. Flux will set up. Flux means magnetic flux. What is happening in the solenoid? Magnetic flux will develop. Okay, then what will happen? The polarity of voltage and current both are positive. Okay, and energy is absorbed. Okay, the first cycle, polarity will become positive, and what will happen? It starts magnetizing. The energy is absorbed. Energy is absorbed and starts magnetizing. The solenoid will become magnetizing in the first quarter cycle. In the first quarter cycle. So that is why it did not start working. You understood now? That is why it took some time to
Yes.
start. Is that clear? Like suppose when you start your computer, it will take some few seconds to boot the system or Windows. Is that clear? To boot the Windows. Is it not? Is that
Yes, sir.
physical explanation?
Yeah.
Someone is asking like how it exactly is working. You are saying like current lags pi/2. That is enough? No. You should know what exactly is happening. When I set up, what is happening? When the voltage is increasing, current is also increasing, and the flux will set up. And what will happen? Flux will set up and it starts magnetizing, and energy is absorbed. The second part. And but now what is happening from B to when the cycle is coming down from B to C, maximum to 0. At that time, what happens? The flux will become 0 in the flux will become 0 in the solenoid. Flux will become 0 in the solenoid. And what will happen? Now energy is returned. Energy starts returning. So that is why it started now. Energy starts returning. So and it starts demagnetizing. And the inductor starts demagnetizing. Next one, the solenoid starts demagnetizing. Now from C to D, again, what is happening? It's a negative cycle. Negative, not the positive, but in the other direction. When I say negative means other direction. The magnetism is applied in the opposite direction. So 0 to minimum. So what happens? Energy is again absorbed. But here the polarity changes. Magnetization will take place. It is magnetizing, but in the opposite direction. As we have you seen in the what is that called? The last chapter, magnetism and matter. We did that experiment. What is that? BH curve. Remember that one? You remember this BH curve? You remember this one? The BH curve. Were you there, Dhruti, at that time?
No, sir, I was not there.
Okay, it's okay. So it was like magnetizing, and that means the polarity is applied in the opposite direction. Again the energy, again here also energy will be absorbed, and polarity changes. Now what happens? Again it is becoming minimum to 0. What will happen? It will the energy will be returned, and then it start demagnetizing. Is that clear now? Is that clear?
Yes, sir.
I don't want to write a story on this one. You should understand. This is a physical meaning of the signal. What is happening in the inductor? Can you explain now? Can anyone explain that? What is happening from A to B, B to C, C to D, and D to E? Who will explain from A to B? Who will explain from A to B?
So from A to B, basically, magnetization will start,
Yeah.
and Yeah, basically it'll start to boot. The magnetization will begin.
Yeah,
Then
very
from
good.
B to C, the current will retain and demagnetization will take place.
Only, yeah, current will become zero to maximum. Current will become zero to maximum. Energy starts absorbing and magnetization taking place. Okay, it starts
Okay.
magnetizing. Who will tell from B to C? Yes, man. Abid Ashas. Sleeping or what?
No, sir.
Tell me then. Speed up. We have to do inductor or capacitor also. Already it is now at 10:50 mark.
So we could hear you. What are you saying?
Will you try, Abid? Abid, will you try from B to C? I'll help you out. Come on. From B to C, current is what happens? The current becomes maximum to zero, and then energy starts. Energy starts.
Decreasing.
Energy starts returning, and it starts demagnetizing. Understood now? Yes,
Yeah.
Ruti, can you try from C to D and D to E also?
Yes, sir. From C to D, again current will move from 0 to maximum, but this time in the opposite direction.
Very good. Very
I
good.
mean, polarity will be in the opposite way, and
Very good.
magnetization also similarly will be in the opposite polarity. Then from D to E, again, current will move from maximum to 0,
Mhm.
and energy returns and demagnetization takes place.
Very good. Very good. And what about D to E then?
D2 is the one I told you right now.
Yeah, energy will be returned and starts demagnetizing. Very good.
Yeah.
So you understood right now? Do you want me to write all these things on the board now?
No, sir, I'm writing it by myself.
You remember, right? So what is happening in
Yeah.
A to B? You can write in your own words. Okay. So A to B, here we can make a tabular column here. So current will become 0 to max like this. Okay. Current will become 0 to max. Then magnet it starts flux starts setup. Okay. So what will happen here? Flux setup will take place, and then energy starts absorbing. The flux, what will happen? It will set up, starts absorbing and all. Okay, that I will send you the notes. Okay, that we can go through. So you understood, right? So can I go ahead with the next one? Can I go ahead with the capacitor thing now?
Yes, sir.
Okay, I'll send you the picture first, then I can start the second one. Now, I'll start with the capacitor now. What is happening to the capacitor? What is the function of a capacitor?
Store electrical charges.
Yeah, it stores electrical energy. It stores electrical energy. Now, now here, AC voltage applied to a capacitor. Now suppose this is the AC cycle and then capacitor. This is the capacitor. Okay, C is the capacitor. Now B is equal to what? B is equal to Bm sin omega. And now C is equal to what? C is equal to Q by V. And B is equal to what? B is equal to Q by C. This you know. This came from the capacitor lesson. This came from capacitor lesson. Okay. Now what is Vm? Vm sin omega t. I'm going to replace that Vm. So we are writing here Vm sin omega t. Vm sin omega t equal to what? Q by C. See, when I'm applying and I is equal to what? I is equal to dq by dt. Current is rate of change of rate of flow of charges is said to be current. I can compare. I did not start still. Okay. So here, what will happen here now? Current I is equal to what now? I is equal to d by dt of q. What is q? Cross multiply this one now. So here we get q is equal to c into Vm sin omega. Sin omega t. I am going to replace this q here. So what will happen? I is equal to d by dt of c into Vm sin omega t. So what will happen? C is a constant. Vm is also a constant. So I'm bringing it outside. C into Vm d by dt of sin omega t. But what is sin omega t? Derivation of sin omega t is what? What is the derivation of sin omega t? What is the derivation of sin omega t?
Cos omega t.
Yeah, cos omega t. And again, omega t derivation is? Omega t derivation is omega. Okay, sin omega t derivation is cos omega t. Derivation of omega t is omega. Is that clear? Is this clear? Please respond. Okay, it becomes very difficult for me.
Yes, sir.
Yeah. Yes, Mr. Abid Ashad.
Yes, sir.
Yes, sir.
Yeah,
Yes,
it
sir.
will be like, a bus, like I'm carrying I'll be, simple example I will give. It's like a driver who is carrying the tourist, and all the passengers are sleeping. What is the purpose of the tourist bus? To show that sightseeing, right? Is it not?
Yes, sir.
Yeah.
If all the passengers
Yes,
are
sir.
sleeping, if the tourist is sleeping, what is the purpose of driving then? Is it not? So now I is equal to what? I is equal to c into Vm. So now what happened? Again, I have to compare this omega t with sine. I cannot directly do it. Okay, so I will compare that. How I am comparing now? Cos omega t is equal to sine of omega t plus pi by 2. This is the way I am comparing now. Okay. So now what I am going to write now? In the place of this, I am going to write I is equal to what? C into Vm into omega sine omega t plus pi by 2. Is that clear? Sine of omega t plus pi by 2. But what is Im? Im is what? Im equal to C into Vm into omega. Im equal to C into Vm into omega. So what is that? I can write
Sir,
here.
there should be a minus, right?
Sine omega t plus pi by 2 is cos theta, no? Sine 90 plus theta.
No, but we are taking from cos omega t, right? So when we differentiate, it should become minus sine.
No. Sine 90 plus theta. It is in second
Oh,
quadrant.
okay.
Sine will become cos.
Sorry.
Okay?
Yeah.
Sine will become
Yeah.
cos. So I is equal to what? So I can write I is equal to what? Im sin omega t. Im into sine omega t plus pi by 2. Plus it came here. Sin omega t plus pi by 2. So what happened now? I'm writing here what is Im. So Im is equal to, I'm writing here Im equal to what? I got here Vm by 1 by omega c. Can I write like this? This omega and Vm, I'm writing 1 by omega c. So here, what is that? Im is equal to Vm by xc. What is xc? Xc is equal to what? 1 by omega c. Xc is said to be capacitive reactance. Okay, capacitive reactance. Is that clear? Again, what is reactance? You know, that is impulse response. Means instead of, I cannot say resistance directly to the capacitor, the resistance which is present inside the capacitor is known as capacitive reactance. Okay. So keep that in the mind. It is also measured in ohms, XC and XL. Both are measured in ohms. Okay, both are measured in ohms. Named after the great scientist George Simon Ohm. Okay. Now XC is directly proportional to 1 by omega c. Means because omega comes here, why omega is equal to what? 2 pi nu. Keep that in the mind. Or 2 pi by 2. So that is why we are writing in the place of omega, we are writing nu. So XC is directly proportional to nu. It depends inversely proportional. Means if you are increasing the frequency, the capacitive reactance comes down. If you are increasing the frequency, capacitive reactance comes down. Okay. So what happens here? Current leads voltage by how much? Because it is plus here. Because there is plus here. So we are writing current leads. So can I write I here? I leads V by 90 degrees. Leads V by I by. Is that clear? So here current is leading. In the previous case inductor, current was lagging. Now, again from the beginning, see here, a capacitor when it's connected across oscillator, the input voltage is V is equal to Vm sin omega t. C is equal to what? Capacitor formula from the second lesson is C is equal to Q by V cross multiply. In the place of V, I'm writing Vm sin omega t cross multiply, again same as it is. Cross multiply, you'll get this one. But this is charge. I want current. Current is rate of flow of charges, dq by dt. D by dt of this one. Then bring these two constants outside. Differentiate sign becomes cos, omega cos. So now cos can be written like sin omega t minus theta is plus theta is cos. So I wrote here. So I is equal to what? The whole thing is Im. So I wrote here. Then after that, I took this fellow here and just I wrote the same thing in the other way, 1 by omega c. So what is 1 by omega c? That is xc. Xc is equal to 1 by omega c. So xc is equal to 1 by omega c, which is measured in ohms. So xc is inversely proportional to nu. Is that clear? In this case, current leads voltage by 90 degrees. Is this clear, all of you?
Yes, sir.
Yeah.
Yes,
So,
sir.
again, we will see the physically how it is happening. What is happening? Like a pulse. I will take a pulse and I'll explain. I will take a picture of this and send it to you. You can copy this one also. See, now did you understand? The first class I was only behind the oscillator, signals, and all. Did you understand now? Is it now easy for you to understand all these terms? Is it easy for you people to understand all these terms now?
Yes, sir.
Yes, Dhruti and Ashas.
Yes, sir.
Okay. Now, I am going to the next term. I am going to explain you the physically what is happening here. Okay. And I will draw the phasor diagram also for you. Okay, the phasor diagram. So then I will stop the class. Okay. Like maybe 3-4 minutes more. Okay. 3 or 4 minutes more. So after that, I will end the class. Okay. Now here, see for one cycle, what is happening in one cycle now? So this is one cycle. This is what A to B, B to C, C to D, D to E. One cycle. What will happen? Now what happens in it is starting from the capacitor. The current is already there is, see in capacitor already it is charged. Means what? What will happen? Already it is charged. So it becomes the other way. It becomes when you apply the voltage, it becomes maximum to 0. It becomes maximum.
So it is opposite to what we did, right?
Yeah, what we did. See, already capacitor is having charges. It's having energy. So when you are applying a voltage across it, it becomes 0 to maximum to 0. Like what is happening when you switch on the fan, you're applying the voltage. What is happening? Already it has to give one rotation, 1 or 2 rotations. So it is started giving that one. So maximum to 0. Now what happens? The energy is absorbed. At that time, the energy is absorbed and the charging will become maximum. Energy is absorbed and charging will become maximum. I'm speaking about the current. Current will become maximum to 0. Now, from B to C, current will become 0 to minimum. Okay, it becomes 0 to minimum. But what will happen? The polarity will be negative and energy is returned in this case. Here, energy was absorbed. Here, energy is returned. Now it starts discharging. Okay, that is said to be discharging. Like magnetizing, like we were saying magnetizing, demagnetizing. Here we are saying charging, discharging. Here it is charging, here it is discharging. Again charging, again discharging. Energy is absorbed, energy is returned. Energy is absorbed, energy is returned, but in the opposite direction. Now, the current, what will happen to the current? Current will become maximum to 0 when we are giving this voltage. Again 0 to minimum and minimum to 0, then 0 to maximum. That is how it happens. Is it clear? Is this
Sir,
clear?
can you repeat the thing again? I'll write it down.
One second, I'll explain. Here, what is happening here in this case?
From where to where is it absorbed?
See, it is absorbing same way. A to B it absorbs, B to C it returns, C to D it absorbs, in the opposite direction, and D to it returns. Okay.
Okay.
Again, A to B charges, B to C discharges. Again charges, again discharges. Okay.
Okay.
Now what about the current? Current will become maximum to 0, 0 to minimum, minimum to 0, then 0 to maximum. Current, about the current. Is that clear?
Okay, sir. Yeah.
So I'll send you the tabular column so that you will understand now how it is charging and
Yes, sir.
okay. So now the last one is the phasor diagram. What is the phasor diagram and the waveform I will explain. So here this is the voltage signal. How should be the thing? So the current should be like this. Is it clear? If this is voltage, this will be the current. Is it clear now? This is omega. If you
Yes,
draw the
sir.
if you draw the phasor diagram, how it should be? If this is the voltage, the current is leading, right, by 90 degrees. Is it not? Current is leading the voltage by 90 degrees. Is it not?
Yes, sir.
Yeah, that's it. Okay, so this completes your capacitor thing and the uh, inductor thing. Is that clear?
Yes, sir.
Just 1 second. Let me check 1 second. Cross check 1 second. Just wanted to check 1 second. Give me 1 second. Yeah, it is set. So here. Sorry, for capacitor is like this. Okay. Made it. That's what I had a doubt for this. Okay. It should be like this.
But sir, that will become out phase, right?
This is for capacitor only. This is correct.
But that looks like out phase, right?
No, this started before that. When voltage was 0, current was maximum.
Oh, okay, okay.
Okay, current was maximum. That's what I was having it out. Okay. Clear? So this completes your 3 circuits. Okay, resistor, inductor, and capacitor. So next class I will be discussing LCR circuit, which is an important one. Once we are done with the LCR circuit, then we have one class will go with LCR and LC transformers and transformer and AC generator will take one more class. Maybe two more classes we can finish up this classes. Finish up this lesson. Okay. Is that clear?
Yes, sir.
Maybe 20th, 21st, and 22nd.
Yes, sir.
So thank you so much. We'll see tomorrow. Okay, I'll just take the picture. Okay, I'll delete the picture and send it a new one. Okay, so thank you so much.
Sir.
Thank you,